Hi everyone, Unit 2, Relations and Functions, Section 2, Linear Functions. This is Chapter 6 in your textbook. So there's a few curriculum outcomes I want to draw your attention to. You will develop algebraic and graphical reasoning through the study of relations. You will demonstrate an understanding of slope with respect to rise and run, line segments and lines, rate of change, parallel lines, and perpendicular lines. Okay, you're going to relate linear relations expressed in various forms. So you're going to learn slope-intercept form, general form, and slope-point form. So these are formulas that are on your formula sheet. Okay, you are going to be able to determine the equation of a linear relation. Okay, and will determine that given a graph, a point and the slope, 2 points, and the point and an equation of a parallel or perpendicular line. You're going to be able to use all of that to solve problems. Yay! Okay, so here's the checklist of requirements to complete this chapter. Okay, so you should have already done the linear functions pre-assessment. If you haven't, please press pause or stop and go and do that now. Okay, then there's 5 parts to this chapter. So the slope of a line, slope of parallel and perpendicular lines, slope-intercept form, slope-point form, and general form of an equation for a linear relation. Okay, there are notes and practice for every part. Okay, then of course, just like the other sections, you will have a linear functions review, formative assessment. Then you'll have a curriculum review, summative assessment. That's the one for marks. And then you will have a linear functions quiz. Okay, that is called a summative assessment, 4 marks based on all of Chapter 6. No unit exam yet. Remember, the unit is Chapters 5, 6, and 7. So you have one more chapter after this one before your big unit exam. Okay, awesome. So let's get started. Okay, Part 1, slope of a line. Okay, now, some roofs are steeper than others. Steeper roofs are more expensive to shingle because of the danger factor. How might you describe the slopes of the roofs below? Okay, and I'm sorry, these don't look great in black and white, but that's okay. They're color here, so how might you describe them? Okay, so this one, it's steep, I guess, steep. This is not so steep, not so steep. Ugh. Terrible writing, my goodness. Not so steep. Okay, and this roof C, look at that's like really steep. Wouldn't want to shingle that one. Okay, now, regardless of how you describe them, if you describe them differently than me, okay, simple words would never be accurate enough for a math class. We need numbers, data, something concrete, okay, to describe how steep these things are. And it's a good thing that we do have something we can describe that with. The steepness of a roof is measured by calculating its slope. Okay, so slope is a measure of the steepness of things. Okay, slope equals rise over run. Okay, so the rise is the up or down part of the line. The run is the sideways part of the line. Okay, so the rise is the vertical distance from the bottom edge of the roof to the top. The run is the corresponding horizontal distance. Okay, for each roof above, we count units to determine the rise and the run. Okay, so for roof A, let's see, so the rise, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units up. Okay, so the rise is 13. And the run, okay, so starting here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units as well. Okay, so the rise is 13, the run is 13, so 13 over 13. So this guy's slope is 1. Awesome. Okay, and we don't have anything to compare that to yet, so it's just 1. It's kind of steepish, I guess. Okay, now let's look at roof B. We kind of describe that as not so steep. Okay, so the rise here is 7, the run is 12. Okay, so that makes a decimal 0.583 repeating. So 0.58. Okay, well that is less than 1. So we can tell that this guy's slope is less than the first roof. Okay, now for roof C, when we count those points, we actually measure 14 units up and 8 units across. Well, that's a slope of 1.75. So we can tell that that is the steepest roof. Okay, roof C is steepest because its slope is the greatest. Roof B is the least steep, or the most shallow, because it is the least slope. Awesome. Okay, the slope of a line segment on a coordinate grid is a measure of its rate of change. Okay, so from chapter 5, recall that a rate of change is the change in the dependent variable, which was always the vertical, okay, divided by the change in the independent variable, which was always the horizontal. Okay, well, the vertical, of course, is the change in y. So rate of change is change in y over change in x. Now, in math and science, we use this funny little Greek letter delta, okay, and that is just a triangle. It means change in. So the rate of change, so change in y divided by change in x, okay, Greek letter delta. Okay, the change in y, we called that the rise. Okay, so the change in y is the rise. So on this particular line, so if I start here, my rise is 1, 2, 3, 4, 5. So my rise is plus 5. Now the change in x is called the run. So the change in x, so from this point to this point, so 1, 2, 3, 4, 5, 6. So the run is plus 6. So the slope is rise over run, so 5 divided by 6. So, and that is just, that fraction doesn't reduce, so that is the slope. Well, that particular line. Okay, and for now, we just count. We're just counting squares. Okay, now, I started from this point right here and went up and over. Now you can also start from this point and go down, so that would be negative 1, 2, 3, 4, 5. So that's a negative 5, but then you also go left 1, 2, 3, 4, 5, 6. So left 6 is negative 5. Oh look, the two negatives cancel, and you're still left with a slope of positive 5 over 6. Great. Okay, so again, for now we're just counting. So determine the slope of each line segment. Okay, so if we start at A and go to B, so that's going to be, so slope equals rise over run. Okay, so the rise, 1, 2, 3, 4, 5, 6. So plus 6, and then the run, so from here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 6 over 10. Now, of course, that's a fraction that reduces. This is 3 over 5. Okay, so that is the slope of A. So in B, if we have a quick look at this, okay, so if we start at G, we go down 1, 2, 3 units. Oh, okay, so that's negative 3. Okay, and then the run, so let's see, that's the rise. Okay, and then the run is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the run is plus 9. So I have negative 3 over positive 9. That reduces to negative 1/3. And if you have a look at this, if we start at G, if we go down 1 and right 3, oh look, we hit another perfect point. So we could have used those. We don't have to go to the end points. So let's see if we can do that with C. Not using the end points. Okay, look, this guy, oh look, that's a perfect point. This is a perfect point. That's a perfect point. This is a perfect point. So I can use any of those. Okay, so if I figure out my slope for C, slope is rise over run. Okay, so if I start from C and I go to this first blue dot, so that is down 2 and right 1. So negative 2 over 1, which is just negative 2. So that is my slope of that line. If we go to the second dot, So that's 1, 2, 3. So that's -4. Okay, and then the run is positive 1, 2. Oh, -2 over, or -4 over 2 is still -2. So it doesn't matter which points you use on a straight line like these, you will always get the same slope. Okay, and then the last one, okay, so look, not a perfect point, not a perfect point, nope. Oh, this one's perfect. Okay, so my slope, again, rise over run. Okay, so 1, 2, 3 up, and 1, 2 over. So +3, so 3 up is +3. 2 to the right is +2. So this works out to 3 over 2. So that's the slope for that one. All right, moving on. There are 4 types of slopes that we have to deal with. Okay, when a line segment goes up to the right, okay, both the x and y increase. Okay, so both the rise and the run are positive, so we call this slope positive. So this is a positive slope right here. Okay, awesome. Positive slope. Okay, we can also start at the other end. We can have a negative rise, but then we have a negative run, and the two negatives cancel. So negative run, negative rise, and the two negatives cancel, so it still ends up being a positive slope. Awesome. Okay, so when the line segment goes down to the right, y decreases as x increases. So this is a negative rise with a positive run, okay, which ends up being a negative slope. So down to the right, so that's a negative slope. Okay, so negative slope, positive slope. Okay, the next two are a little bit weird, but that's okay. So for a horizontal line segment, the change in y is 0. Like there's no rise. Okay, but x increases, so there's lots and lots of run. So we have a 0 divided by anything, or lots, or whatever. 0 divided by anything equals 0. So the slope of all horizontal lines is 0. Okay? So we have a positive slope, a negative slope, 0, and the last one, for a vertical line segment, y increases and the change in x is 0. So the rise is positive, so it's any number, and the run is 0. So rise over run. Okay, so lots of rise divided by 0. Ugh. Okay, well remember, we are never allowed to divide by 0. A fraction with a denominator of 0 is called undefined. On a TI Inspire, if you try and type that in, it'll actually say undef. Okay, on the TI-84, if you try that, it'll just say error divide by 0. Okay, divide by 0. Okay, so any vertical line segment has a slope that is undefined. Okay, so we have positive slope, negative slope, 0 slope, and an undefined slope. So 4 that we have to deal with. Okay, next page, example 2. So drawing a line segment with a given slope. Okay, so draw the line segment with each slope. You can draw them on the same grid below. So 4/9, and I want you to start at A. So remember, slope is rise over run. So that means we're going up 4. So from A, we go up 4. 1, 2, 3, 4. Okay, and then positive 9. So the run is +9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's the other point. And then if you have a ruler, please use it. If you don't, just try the best you can to make that line as straight as you can. And so there's your line with a slope of 4/9. Okay, and then B is -8/3. Now remember, a fraction usually has that number out in front. Okay, so that negative really can go to the top, so that can be -8/3, or it can be +8/3. Okay, it doesn't matter, it's all the same. Okay, I'm going to use this first one because that's what I left you guys room for. So starting at B, it's rise over run, so you go 8 down. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 down. and then we go plus 3 to the right. So 1, 2, 3. Okay, so that's the dot, and then we draw the line. Okay, as straight as you can, rulers help. And you can tell right now, okay, just from that last page, this is a positive slope. This guy falling down to the right is a negative slope. Awesome. Okay, so that is how we draw the lines. Okay, example 3. Okay, determine the slope given 2 points on a line. So determine the slope of the point that passes through 4, -5, and 8, 6. Okay, so let's graph these first. So 4, -5. So this didn't show up all that well on the graph. Sorry, guys. That's the graph. Okay, so this is the origin, 0, 0. Okay, so 4, -5 goes 1, 2, 3, 4, and -5. 1, 2, 3, 4, 5. So that's this point. That is point E. Okay, then point F is 8, 6. So 1, 2, 3, 4, 5, 6, 7, 8, and 6. 1, 2, 3, 4, 5, 6. So that's that point right there. That's F. Okay. So I can draw the line through that if I really want. Why not? Now, slope, remember, equals rise over run. So this is a positive slope. We can tell that right away just by looking at it. Okay, so the rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we go 11 up. And the run is 1, 2, 3, 4. So 11 over 4. So this guy's slope is 11 quarters. Okay, now hopefully you saw the inherent flaw in this. Okay, if I give you 2 points and ask for the slope, you're not going to want to graph every single one of these things and count to get the slope. There's got to be a different way. Now, if we look at the numbers on the points, we can get clues as to how to find the slope without drawing the line. Now, look, the run talks about the vertical coordinates. Okay, sorry, pardon me, the rise talks about the vertical coordinates. Woo. Okay, so if we start at -5 and go up to 6, how far did we go? So -5 to 6. Okay, that is 11 spaces. And how we can do that using math, if we take the top one, so 6 minus -5. If we minus those, hey, look, that gives 11. Let's see if that works for the run as well. Okay, the run we went from 4 to 8. Okay, so if we take 8 minus 4, that equals 4. Hey, look, it worked. So the 11 was the rise, the 4 was the run, okay, and we could do that without graphing if I wanted. Okay, so the slope of the line, and this is on your formula sheet, so if the line passes through A, or point A, which is through x1, y1, and B, x2, y2, the slope of the line AB is denoted with the symbol M, so we're going to use M for slope. Okay, so slope equals M equals rise over run, and then we take the 2 y coordinates and subtract them, and divide it by the 2 x coordinates subtracted. So y2 minus y1 over x2 minus x1. So this is on your formula sheet. M equals y2 minus y1 over x2 minus x1. Okay, so the rise, like we said, y2 minus y1. The run is x2 minus x1. Perfect. So that's a nice little formula that you can now use. Okay, example 3. Interpret the slope given a line. Okay, Tom has a part-time job. He recorded the hours he worked and his pay for 3 different days. Tom plotted these data on a grid. Okay, what is the slope of the line through these points? Okay, so let's see. Slope of the line here. So this point is at 224. Okay, this next point is at 448. Now, we can do the third point as well, but you only need 2 points to figure out the slope. Now, it doesn't matter what you label these. I usually start with this. So this guy is going to be my x1. This one's going to be my y1. Okay, so that makes 4x2 and 48y2. Really, it doesn't matter. You could have, so if I draw in red, you could have made this x2, y2 and x1, y1. It doesn't matter as long as you put the 1s and the 2s on the same point. So you can never have x1, y2. It just doesn't work that way. Okay, so x2, y2 or x1, y1. Okay, you know what? I like to label the first point with the 1s because they're first. Okay, so x1, y1, x2, y2. And then the formula is slope equals y2 minus y1 over x2 minus x1. So y2 is 48, y1 is 24, x2 was 4, and x1 was 2. So we just plop in the numbers and then subtract. So 48 minus 24 is 24. 4 minus 2 is 2. So 24 divided by 2 is 12. Okay, so that is my slope. Okay, so what does the slope represent? Well, look, the rise over run, so that's the slope. The rise is measured in dollars, and the time is measured in hours. So the slope has units of $12 per hour. Hey, wait a sec. That's his hourly rate of pay. So what does it represent? His rate of pay. So he makes $12 an hour. Okay, so how can you use the answer to B to determine how much Tom earns in 3 hours? Okay, so if I earn $12 per hour times 3 hours, well, that's $36. Okay, and what about the time it takes to earn $30? So $30 is equal to $12 an hour times a certain time. Okay, so then, oh look, 12 times t, so we divide by 12, and t equals 2.5 hours. Okay, so that's that. That's great. Okay, so we're done section 6.1. I want you to practice the material from here. Again, section 6.1 in your textbook starts on page 339. You might want to print these ones from the workspace card because there's some drawing in here, and it's just easier if you just draw right on the pages. Please don't draw on your textbook. Your librarian gets kind of annoyed at that. Okay, so anyways, please do these questions. Remember, you can always do more, but at least do those and then show your teacher when you're done. Good luck. We'll see you next part.